spherical balloon is inflated with gas at a rate of 300 cubic centimeters per minute. So what is that? If you're pumping gas into this balloon, what is that changing? Okay, so that's V prime. They expect us to get that out of there. How fast is the radius of the balloon increasing? So the rate of the radius is what we are set to find at the instant when R is 70 centimeters. Okay, so those are the things given to us. So we need to recall some formula. So something to do with the sphere, that includes volume and radius, and so that's probably going to be the volume of a sphere. This is one formula that you do not have to memorize. Every time we've ever seen it in a released AP question, they've always included it in the question. So we would do the same thing for you guys. Probably should put it in this one too. Okay, so what happens when I take the derivative of the left side? What does this become? Okay, because we're taking the derivative of v with respect to time. Related rates are always with respect to time. Over here, 4/3 pi is just a number. So r cubed, we can just do like the power rule. We could bring the power down, lower the power by 1, and then I just took the derivative of r with respect to time. So that's why we have needed this r prime. Hopefully that's pretty intuitive to you now, where you just do it without thinking about it too much. It's okay if it's not, but you do need to be careful in those steps. Now, if you forget something like this, you're probably going to catch it in a question that's this short, because that's the whole point of the question, to find r prime. So if you forget it here, you don't know what you're solving for. You're going to be confused. If we plug in the stuff given to us, we have an equation with only one unknown, which is good news, because the one unknown is what I want to solve for. So divide both sides by 40 pi times 70 squared centimeters squared. I guess to finish this question, we kind of need to, well, if this was an FRQ, you could pretty much be finished here. I'd say the one thing that you probably would lose points for on an FRQ, though, is you do need to at least clean up the units. Centimeters cubed divided by centimeters squared would give you centimeters, which makes sense. Radius is just the length per minute. But then if you wanted to leave the rest of this mess in as an FRQ, that is perfectly fine, as long as it's equivalent to what the answer is supposed to be. But as multiple choice, or in our case, I can look at the answers on the back, and they changed this to a decimal. So in that case, if we did that to you, it would have to be a calculator question. So in my calculator, if I do 300 over 4 times pi times 70 squared, I get 0.00487. And that should be the answer. Did you happen to get an answer similar to that? All right, have y'all looked at the answer on the back page of this one? There's actually a typo. It's missing a 0 in it. It should be 0.00487. You see what I'm saying on the answer key? So it squeezes 0 in there in case you rework this one later. Number 9 on the back page for answers. So don't worry about memorizing the volume of a sphere formula. That's not a problem. But if you're regularly still forgetting b prime, r prime when you do derivative, then it sounds like you need to keep practicing more of those.
Can you list some of like the most common